Hello everyone, this is Dr. Sunita M. Today we'll study about epsilon closures in NFA. Okay, first let us know what is epsilon closures. See, epsilon means present state can go to some other states without any input symbol. So, what does this mean? Without any input symbol, it may go to some other state, that is from one state to the other state with just an epsilon symbol. It may go to the other state. This can happen only if the present state have epsilon transition to the other side. That is, there should be a transition with epsilon symbol from one state to the other state. Okay, or epsilon closure is finding all the states which can be reached from the present state on one or more epsilon transitions. So without any input symbol, if epsilon symbol is present, then we can move from one state to the other state. Let us see few examples. Okay, see first, this is an example. Just we'll find the epsilon closure of this. How many states are there in this? 3 states. Okay, Q0, Q1 and Q2. How many input symbols are there? 3 again, A, B and C. Okay, we'll write the epsilon closures for this. So, epsilon closure of Q0 first. Epsilon closure of Q0. Okay, what it will be? Wherever epsilon closure is connected from Q0. Okay, those many states. So initially we should take the same state for all which we are going to write for the epsilon closures. For that particular state, initially we should write the same state first. So Q0 means first we should write Q0. Okay, comma. Next, where epsilon symbol is connected from Q0? Q1. Okay, next state is Q1. But again from Q1 epsilon symbol is connected. Where it goes, that is Q2. Okay, so these are the 3 states of epsilon closure of Q0. Okay, next epsilon closure of Q1. Okay, the same state first. Okay, next, which is the epsilon symbol connected to Q1? Which is connected here? Q2. Okay, Q1, Q2. Next, epsilon closure of Q2. Okay, the same state first. Is there any epsilon symbol connected from Q2 to some other state? No. So only Q2. Okay, so epsilon closure should be written first the same state itself, then whichever the symbol is connected from that particular state to some other state. Okay, so here these are in this transition diagram, there are 3 states with the 3 input symbols. Okay, and 2 epsilon symbols are connected from Q0 to Q1 and Q1 to Q2. Okay, which Q0, where Q0 is a start state and Q2 is a final state. So epsilon closure of a Q0 will be what? Q0, Q1, Q2. Epsilon closure of Q1 is equal to the same state first, then the connecting state, that is Q2. And epsilon closure of Q2 is equal to what? The same state, that is Q2. Okay, this is just how to write an epsilon closure for that particular state. Okay, we'll see the next example. See here, in the second example, epsilon closure of Q0. See how many states are there in this transition diagram? There are 4 states: Q0, Q1, Q2 and Q3, where Q0 is the initial state and Q3 is a final state. Okay, and what are the input symbols connected to this? A and B. Okay, A and B are the input symbols connected to this. And from Q0 to Q2, Q0 to Q1, Q1 to Q3, Q2 to Q3, epsilon symbols are connected. So we'll write the epsilon closure of each state. Okay, so epsilon closure of Q0 first. So Q0 will be what? The same state first. Okay, and the one from Q0, epsilon symbols connected to the other state. Okay, Q0 to Q1 first. Okay, Q1 to Q3 is also there. Okay, next Q0 to Q2 is also there. So already Q0 is there, no need to write. Next, okay, Q2 to Q3 is also there. So all this. So this implies Q0, Q1, Q2 and Q3 states. Okay, for Q0. Next, epsilon closure for Q1. The same state first. Okay, Q1. Next, Q3. Next, is there any other transition from Q1 with the epsilon symbol? No. Wait. So Q to Q3. Okay. See here. So only Q1 and Q3 are there. Is there any other epsilon connected from Q1? No. So only Q1 and Q3. Next, epsilon closure of Q2. Okay. First the same state. Next, from Q2, is there any outgoing transition with the epsilon symbol? No. So only Q2. Because Q2 to Q3 is B. Okay. Next, epsilon closure of Q3. Okay. The same state first. Then, is there any outgoing transition from Q3 state with epsilon symbol? No. So, Q3 itself will be the epsilon closure of Q3 state. Okay. This is how we need to write the epsilon closure of each state. We'll see one more example. See, in this, how many states are there? Again, 4 states are there with what are the input symbols? Again, A, comma, B. Okay. And E is nothing but epsilon. So, we'll write first for epsilon symbol. Okay. Epsilon symbol, epsilon closure of Q0. Okay. What it will be? Where it is connected to the same state first. Okay. Q0 to Q1. Q1 to Q2. This we can take it as Q3. Okay. Because already Q2 is here. So that will be Q3. Okay. Q3. So Q0, Q1, then Q2. From Q2 epsilon symbol is there, yes, Q3. Then from Q3, Q1 is also there. But Q1 already we have taken, so no need. Next, epsilon closure of Q1. Okay. Epsilon closure of Q1 means the same state first, that is Q1. Then from Q1, what are connected again? Q2 is connected. Okay. Next from Q2, what is connected? Q3. Again from Q3, it is connected to Q1. So no need. Because already Q1 we have taken the state, so no need to repeat the state. Next, epsilon closure of Q2. Okay. The same state first. Okay. Q2, Q3. Then from Q3 it is going to Q1. Then again from Q1 it is going to Q2. So don't take Q2. So this implies Q1, Q2 and Q3 states. Okay. Next, epsilon closure of Q3 state. Okay. The same state first. Then from this state where it is going epsilon symbol to which states again? Q1. Okay. Next from Q1 to Q2 also it is there. Then from Q2 to Q3 again it is coming back. But already Q3 we have taken. So no need. So this implies Q1, Q2 and Q3. Okay. This is how we need to write the epsilon closures of those particular states. Okay. Whatever might be the state, if epsilon symbol is connected between the two states, those many states we should consider. Okay. We'll now convert epsilon NFA to NFA, just epsilon NFA to NFA. Okay. See, this is the example we have taken. Convert epsilon NFA to NFA. How many states are there again? 3 states. Q0, Q1, Q2. Okay. 3 states. How many input symbols? 3 input symbols. A, B, C. Okay. First, we'll write the epsilon closure of all this. Or else, we'll write... Okay. First, we'll write the epsilon closure. Epsilon closure of Q naught will be what? Q naught, the same state first, next Q1, next Q2, because epsilon is connected. Next, epsilon closure of Q1. Okay, Q1 first, then Q2. Epsilon closure of Q2. What it is? Q2 only. Okay, these are the epsilon closures. Next, first write the transition table of this with the epsilon symbol. So A, B, C with epsilon. Okay, this will take a transition dash. Q naught is a start state, Q1 and Q2 is a final state. Q naught on A, Q naught only. Q naught on B, null set. Q naught on C, null set. Q naught on epsilon, Q naught. Q naught on epsilon, Q1 as well as Q2 it is there, right? So just only we'll write a Q1. Next, Q1 on A, null set. Q1 on B is Q1. Q1 on C, null. Q1 on epsilon, where it is going? Q2. Q2 on A, it is null. Q2 on B, it is null. Q2 on C is Q2. Okay, Q2 with epsilon is null. Okay, so this is just a transition table for this particular NFA with epsilon symbol. So now we'll convert, okay, this to normal NFA, that is non-deterministic finite automata. Okay, sorry. First, we'll write delta dash of Q naught on A. Okay, we'll start with start state, that is Q naught. So Q naught on A is equal to epsilon closure of delta of epsilon closure of Q naught on A again. Okay, so epsilon closure of delta of epsilon closure of Q naught is what? Epsilon closure of Q naught is what? Q naught, Q1, Q2 on A. Okay, just we are writing the epsilon closure of Q naught. Next, epsilon closure of transition of Q naught on A is what? See the transition table. Q naught on A is Q naught. Q1 on A, null set. Q2 on A, null. So again, epsilon closure of Q naught will be what? Q naught, Q1, Q2, right? Next, epsilon, that is delta dash transition of Q naught on B. Epsilon closure of delta of epsilon closure of Q naught on B. Okay. So here epsilon closure of delta of, what is epsilon closure of Q naught? That is Q naught, Q1, Q2 on B. Okay. Epsilon closure of Q naught on B is what? Null set. Q1 on B is Q1. Q2 on B is null. So this. So epsilon closure of Q1 is what? Q1, Q2. Q1, Q2. Okay. Now delta dash of Q naught on C. We need to find for all delta dash of Q naught on A, Q1 on A, Q naught on C, that is A, B, C, Q1 on A, B, C, Q2 on A, B, C again. So epsilon closure of delta of epsilon closure of Q naught on C now. Okay. So epsilon closure of delta of epsilon closure of Q naught on C. So what is Q naught here? Epsilon closure, that is Q naught, Q1, Q2 on C. Okay. So Q naught on C is what? Null. Q1 on C is again null. Q2 on C is Q2. Okay. Epsilon closure of Q2 is what? Q2. Just if you write this in the form of a table, it will be easy. So where we'll write? Okay, I'll just write here somewhere table. Okay, so that it will be easy for us to draw the transition diagram. Okay, that is delta of not delta dash, this is for delta q0 q1 q2 on A, B, just to see. Okay, q0 on A is q0 q1 q2, q0 on B is q0, that is q1 q2, q0 on C is q2. Okay, okay, next we'll write for q1 on A, B, C, q2 on A, B, C. Okay, just I'll erase this because already I have written this in the form of a table, so no need. So just I'll erase. Next we'll write for delta of q1 on B, A first. Okay, so this is epsilon closure of delta of epsilon closure of q1 on A. Okay, epsilon closure of delta of epsilon closure of q1 is what? q1 q2. Okay, on A, q1 q2 on A. This is epsilon closure of delta of q1 on A is what? q1 on A is null. Okay, null. q2 on A is again null. So null. So this will be what? Null. So I'll write here in a table. Okay, next delta of q1 on B, that is epsilon closure of delta of epsilon closure of q1 on B. Okay, so now epsilon closure of delta of epsilon closure of q1 is what? q1 q2 on B. Okay, q1 q2 on B is what? Transition of q1 on B is q1, q2 on B is null, so only q1. So epsilon closure of q1 is what? q1 q2. So just you write q1 q2. Here also I'll write q1 q2. Okay, next delta of q1 on C. So epsilon closure of delta of epsilon closure of q1 on C. Okay, so epsilon closure of delta of epsilon closure of q1 is q1 q2 on C. Okay, epsilon closure of delta of q1 on C is q1 on C is null, q2 on C is q2. So epsilon closure of q2 is what? q2 only. Okay, so just I'll write here it as q2. Now q0 is over, q1 is over. Now we'll find for q2. Okay, I'm erasing this. So next we'll find for q2 on A, q2 on B, then q2 on C. Delta of q2 on A. Okay, transition, that is epsilon closure of delta of epsilon closure of q2 on A. Okay, epsilon closure of delta of epsilon closure of q2 is what first? q2 only. So q2 on A. Okay, transition of q2 on A is what? q2 on A is null. So this will be null. So simultaneously I am writing transition table. Okay, because I am erasing here, so simultaneously I am writing the form of a table, that is transition table. So q2 on B now. Epsilon closure of transition of epsilon closure of Q2 on B. Okay, epsilon closure of delta of Q2, epsilon closure is what? Q2 only. So Q2 on B. So transition of Q2 on B is what? Q2 on B is null again. So epsilon closure of null is what? Again null. So here null. Okay, transition of Q2 on C now. What it will be? Epsilon closure of transition of epsilon closure of Q2 on C. Okay. Epsilon closure of Q2 is what? Q2 only. So epsilon closure of delta of Q2 on C. Okay. Q2 on C is what? Q2. So epsilon closure of Q2 is what? Again Q2. Epsilon closure of Q2 is Q2 only. Okay. So this last is Q2. Now we have found all transitions of Q0, Q1 and Q2 on all the three input symbols A, B and C. Okay, I have written in the form of a table also. So using this transition table, this table is without an epsilon symbol. Okay, but previous this what we have written was with an epsilon symbol. Okay, see here this was with an epsilon symbol and this is without an epsilon symbol. Okay, now we can directly draw the transition diagram. Okay, just I'll erase this. Yeah, how many states are there here now again? 3 states. I'll draw just Q0, Q1, Q2. Okay. Q0 on A, where it is going? Q0 also, Q1 also, Q2. See here in NFA, what was the final state? Q2. So wherever Q2 will be there, right? There will be those many states will be the final state. So Q0 on A is Q0 only. Q0 on A is Q1. Okay. Q0 on A is Q2 also. So Q0 on A is Q2 also. See, I'm drawing. On A. Okay, this is also A. But see, Q0 is linked with Q, is present as Q2 also. So this will be the final state. Next, Q0 on B. Q0 on B is Q1. Next, Q0 on B is Q2. Like this. Okay. Next, Q0 on C is Q2. Okay. Next, so in Q0, see Q2 is there. So this will be the final state. Q1, Q2. All three states will be the final state. Next, we'll go with Q1. So Q1 on A is null. Q1 on B is Q1, B as well as Q2 also. So this is B also. Okay. Next, Q1 on C is Q2, comma C. Okay. Next, Q2 you see here. Q2 on A is a null state. Q2 on B is again a null. Q2 on C is Q2. On C is Q2. Okay. So this is the transition diagram without an epsilon symbol. So this was with an epsilon symbol and this transition table is with epsilon symbol. We are converting this epsilon into a normal NFA. So this table is without an epsilon symbol and this is also without an epsilon. So now check whether this is an DFA or NFA. NFA, because just a normal NFA, because it reaches from one state to the other state with one input symbol. It is reaching to more than one state, which is nothing but what? NFA. More than one state if it reaches, it will be an NFA. But whereas in DFA is only one and with one input symbol, it should reach to only one and one state. Okay, that is DFA. So hence this is how we are going to convert an epsilon NFA into NFA. Okay. So these are just textbooks and references you can go through. Okay. Thank you.